Hi, my name is Amy Knowles. I'm an instructor at New Mexico Tech University. I teach in the computer science department, entry-level computer science classes. I've also taught a few in computer graphics, video game design, high-performance computing. So I've done a few of the a few kind of extracurriculars, I guess. But mostly what I'm doing now is introductory level courses. So introduction to C, introduction to programming in C, introduction to programming in Python, and then a 101 class where we kind of delve very lightly into a number of different topics within computer science as a discipline, as well as teach them various different kind of tools like LaTeX and Git that will be useful as they go through their career as college students. So what I'm going to show you here today is kind of data visualization with the Matplotlib library within Python. It's pretty cool. It produces publication quality figures in a number of formats and interactive environments across platforms. So this is really kind of me creating these plots in an interactive environment using Jupyter Notebook. So this is a Jupyter Notebook that I've built within Visual Studio Code. So in the context of the supercomputing challenge, Matplotlib can really make your final project shine because it's going to allow you to generate pretty simply really nice looking figures for your report. You can check out a lot more about Matplotlib here at this particular index. Or at this website. This is just basically all of the documentation that surrounds Matplotlib. It's also got more examples of code and of how to generate various different types of charts. There are some things I've kind of assumed when I built this particular kind of module on Matplotlib and the visualization is that you have some experience with Python. Generating a Hello World program is pretty easy for you. You know how to import various different modules. You might even have experience drawing with the Turtle module, but ultimately you don't need to have a whole lot of experience with Python in order to utilize the Matplotlib module, which is really kind of the glory of Python. Mostly a little bit of perseverance is going to go a long way here. And Matplotlib is really good at making easy things easy and hard things possible. So as we go through this, our original kind of charts are going to look a little boring, but as we get through, kind of do some of the demos towards the end of the end of the lecture will be pretty interesting looking charts and graphs that you can create utilizing Matplotlib. So the first thing you're going to want to have in order to run charts in Matplotlib is some kind of version of Python. I would suggest Python 3. If you run this command in a Linux environment and it errors on you, then you'll need to install Python here. So these are the instructions to install actual Python. Once we have Python 3 installed, we need to install the package manager for Python 3, which is called pip. And once we have pip installed, we can then utilize pip to install the Matplotlib module or library for Python. So once we have all of this done, I of course already have this done on this particular system. So let's begin to take a look at a pretty simple figure. It's going to be a basic line graph. It's going to be a little boring at first, but we're going to get into some pretty interesting looking figures. And by the end of this, you'll have a number of different tools kind of under your belt within Matplotlib to create some pretty nice looking charts and graphs. So as some famous guy once said, a journey of 1,000 miles begins with a single step. So let's take our first step into this journey with Matplotlib. So this is going to be our first basic plot here. Okay, we're going to generate a very basic line graph. It is going to have 4 data points, and those data points are going to be, where did it go? Oh my goodness. So it's going to generate here the y-axis. So these values 1, 2, 3, and 4 are going to be based on their location is going to match to an x-axis. So this is the first element in this list of Python. So it's going to be y1, x1. This here is my second piece, my second element within my list. So it's going to be y2, x2. This one is going to be y3, x3, and then y4, x4. So if I take a look at this, it's going to make a very basic line here. So here we have our 0, because this is in the 0th location. Sorry, I did get that, got that backwards. So in Python, our elements, of course, when we start counting in lists, we start at 0. So this is the 0th element, the first element, the second element, and the fourth. So at 0, 1, we have this point. Our next one is at 1, 2. Our next one is at 2, 3. And our last one, of course, is at 3, 4. Where these are determined by default based on the location of these elements, of my Y elements within my list. So far, it's kind of boring. So let's begin to add some things, to this basic little line chart here. And the first thing we might want to do, of course, is to add some kind of axis label. We might want to say what this data represents and what this line represents. What's going across my x-axis and what's going across my y-axis. I can do that by simply plotting my y label and my x label. Okay, where y label is going to provide some kind of text string that I can have a label for my y-axis, and x label is going to allow me to input a text string that will allow me to label my x-axis. So here we are actually beginning to have a chart, and we have a label on my x-axis and a label on my y-axis. So if you could turn in all kinds of, if your charts always look like this when you turn them in for your maths teachers, I bet they'd be pretty excited because these are very easy to read. So now that we can label our axes, let's go ahead and provide some actual x-axis data to our chart. So in other words, instead of letting this go by default, we're going to provide values to match with my y-axis value. So it's going to generate basically coordinate points for my particular plot, where the first elements of x and y are going to go together. The second elements of x and y are going to go together. The third elements and the fourth elements. So here, if I run this, right, I now have my 1 is associated with the value 1. My 2 is associated with the value 4. My 3 is associated with the value 9. And my 4 is associated with the value 16. So these are going to be the values I'm going to square, and these are going to be the squared output of those values as I begin to kind of see the curve of this line. But I would still say this isn't quite perfect because it's kind of hard to see where our data points are. So maybe we want to see those data points. Maybe they're important to the data, to the actual figure that we're generating. We want to be able to look at them. We want to be able, in other words, to alter the way that the data appears within our figure. So Matplotlib, by default, generates a blue line. So this would be the equivalent to a text string lowercase b and then a little dash. And that's how it generates everything by default. We can change this. So if we wanted to view the same chart, but have it show up as red pluses, in other words, it's going to make markers and it's going to stamp. It's going to put a red plus stamp at 1, 1, a red plus stamp at 2, 4, a red plus stamp at 3, 9, and a red plus stamp at 4, 16. So if I run this, I can see those red stamped pluses at these relevant locations for my data. So I've altered the way the data appears, and there are all kinds of ways I can alter the way that this data appears. I have a number of different colors to choose from. Okay, where again, blue is the default, but I could use green or cyan or magenta. I can make yellow. Some of these get a little difficult to read depending on what your background color is, which you can also change. And then you can change the style of the actual line. So here's a few options. The single dash is going to be the solid line, which is why I said our default style here, right, is going to be B for blue, and then the single dash, which makes a solid line. If I want to have a dashed line, okay, I have my double dash. If I want to have the kind of dash dot, dash dot, dash dot line, I can use dash and then a period. A colon is the one that's going to make a pure dotted line style because a single period makes a kind of point marker. So kind of a circle. is what that one does. So now we can begin to actually alter the way that our data appears by using some of these options above. And we can use these options to differentiate between two different kind of data sets that we can place into a single figure. So here I have one data set that is going to be red plus marks or stamps. And then I have another data set which is going to have circles. So it's going to be a blue solid line with circle dots along that line at my individual points. So it will create a solid line that is blue, and then there will be blue circles at 1, 1, at 2, 2, 3, 3, and 4, 4. And the way this one is going to work, because this plot is drawn last, it's going to end up being rendered last. The blue will override the red here at the 1, 1, because they both have the same starting point. So here we can see that our red plus got overdrawn or over rendered really, where the blue line was drawn. So we have our B0, so it's a blue solid line with circles at our significant data points. And then this top one, we have the stamped things here. Once I can also, of course, build the exact same plot by adding these into a single function call. Okay, where this is going to be information about my first chart, and this is going to be information about my second kind of data set. And so here it generates again the exact same chart. I've just done it here with a single function call as opposed to multiple function calls. So it just looks a little bit easier. We can also change things like the label. We can change line width, and we can change marker size. So we can make these stamps bigger. That's going to be the marker size. We can make the thickness of this line a little bit wider, which is going to refer to line width. And we can label each one of these data sets here in a specific legend. We just need to tell Matplotlib to include a legend. So here I am adding a label. So my first plot is going to be line 1. It's going to be the label for line 1. The second plot is going to have a label of line 2. I'm going to make my red pluses slightly larger. They're going to have a 10-point font size, and here I'm going to have a line width of 5. So it's going to increase the width of that this line here, make it a little bit thicker. And because I have added these labels here, I need to tell Matplotlib to include a legend for my little chart graph. And I can do that simply with plot.legend. So if I run this one, we now have a little legend up here in the top corner of our chart. And because we made our stamp slightly larger, I can begin to see that there is a red plus poking outside of this particular blue line. We can also see that the blue line has gotten a little bit thicker than it was by default, and we still have our little circle dots here that mark our 1, 1, 2, 2, 3, 3. This should be a 4, but I never noticed it, so it's fine. That marks off our particular points here. Instead of putting them on the same chart, I can also generate subplots that will create two different plots and put them in the same kind of figure. So it kind of makes them a little bit smaller. And I do this with the subplot function. And what these mean here, so this 2, 1, 1 and the 2, 1, 2, this refers to the number of rows within my subplot figure. Within my figure, this refers to the number of columns. The second digit refers to the columns. And the third digit represents the order that I want to have these particular subplots in. So this is going to have 2 rows. It's going to have a single column. And this first subplot here is going to be the first plot it's going to be the one generated on the top. Basically the same thing down here. It's going to have 2 rows. It's going to have a single column, and it will be the second plot generated within my figure. So if I go ahead and hit show, I can see that I have 2 kind of miniature plots, one stacked on top of the other, where my red plus plot that I marked first is going to be on the top, and my blue one is going to be on the bottom here. I'll show you another couple of ways in some of the later demos, another way to kind of do this subplot where maybe we don't have to use these kind of wonky numbers, where I can input a whole bunch of plots and just call the plot subplot and let Matplotlib kind of do some of this organization for us. Outside of line graphs, one of the more interesting graphs we can make, or one of the more useful graphs you might use in your projects, is a bar chart. We can do this with the plot.bar function. And so a couple of things with our bar. Here I am using list notation in Python. So what this is going to do is it's going to create the values 1, 2, 3, and 4. Okay, in Python, range goes from your starting value up to, but not including, your end value. So had I just put 4, it would only give me the values 1, 2, and 3, and I would kind of have a hanger here of 16 that didn't have an x plot to go with it. So that's why I have it specifically written 4 plus 1 to show that this is supposed to have the numbers 1 through 4. So 1, 2, 3, and 4. It will go up to, but not including 5. It will align these charts. It will align these bars on the center of the pick, or center of the tick. So if the tick is here, the center of the bar is going to align with the center of my tick. And then each one of these bars are going to be 0.5 of a tick wide. So let's go ahead and take a look at this particular bar chart. So we can see here that we have it aligned. The center of my bar is aligned right at the center of the tick. Each one of these ticks is about half, is 0.5. So what we have here is that on either side of this tick, we actually have 0.25. With the total width of 0.5 for each one of our little bars. By default, the width of a bar, so if you don't set it yourself, the width of a bar is going to be 0.8. So it's going to take up almost an entire unit here with very little space in between our bars. So generally, when we make a bar chart, like at this point, these ticks don't really mean much right now. We generally want to have some kind of specified label for each one of these bars. So maybe this is growth over a period of time. Maybe it's the number of students that dislike my classes as I teach longer and longer. But we want to maybe generate a specified kind of legend for what these values actually are. Maybe they're years, maybe they're months. But we could do that with something called xticks. So here we are generating the exact same little chart here. And then I am creating a secondary list where this is going to put G in front of each one of these. So I'm going to have G1, G2, G3, and G4. And then I'm going to use my xticks function to say, okay, for each one of the values in list, instead of putting 1, 2, 3, 4, I want you to put the values that I've stored in glist, which is going to be G1, G2, G3, and G4. So if I show this plot, I have now relabeled each one of these little bars within my bar charts. And of course, just like I could put 2 lines on a single line graph, I can put kind of put 2 bar charts into a single bar graph figure. And there's a couple of ways that I can do that with bar graphs. I can set one graph on top of the other, or I can set one graph to the side of the other. So let's take a look first at what it's going to mean to set one bar chart on top of the other. So here I am using the exact same X range. So I'm using the same kind of X tick range down here, where I'm using 1, 2, 3, and 4. And then my top bar chart is going to be 1, 4, 9, and 16. I'm going to go ahead and let it use the default blue color. I'm going to set the bar width to 0.5, and I'm going to have it centered on the tick for that particular axis. And then my second one is going to be 1, 2, 3, 4. It's going to have, I'm going to set the color to red so that I can see some kind of visual difference. I'm still going to have it centered on the tick, and then the width is still going to be 0.5. So when I run this, what's going to happen, right, is that my red line is going to render last. So it is going to cover up the 1, 1 plot here, because the red is going to basically get colored over the blue. Here I have my red goes from 2, 2, but my blue goes to 2, 4. Okay, my red here is 3, 3, but my blue one goes from 3, 9. So I've basically set one kind of bar chart on top of the other bar chart. And the second way to kind of do this is to set one bar graph beside the next bar graph. And we can do this by offsetting the midpoint for the second bar graph. So let's take a look kind of at how we might do that. So here again, I have my my same entry bars. And then for this one, again, I have used list notation in Python. And so for every I in this 1, 2, 3, and 4, I'm going to add 0.5. So that it's going to be, we're going to have my second one sit at 1.5, 2.5, 3.5, and 4.5. So 1.5 will have 1, 2.5 will have 2, 3.5 will have 3, and 4.5 will have the value 4. We'll still have our red lines. They'll still be centered on their tick. And the width will still be 0.5. So if I run this, okay, if I run this piece, I've kind of got my bars close together. They're kind of all smushed in here, but my reds are centered right on the 0.5 ticks, and my blues are centered on the numeral ticks. And I've got one set of data sitting right next to another set of data. Well, what if I wanted to label these? So maybe we're comparing over some kind of time period two different elements, right? So this is a comparison of the first element, or this is maybe the first time set to compare these two elements. This is the second time step to compare these two elements, the third and the fourth to compare these two elements. So I might want to label these with a single X tick. Can absolutely do that. So here, at this point, we're still pretty much the same as we were above. What I'm going to change here is that I'm going to take my starting point, my I, I'm going to add the width of my bar, which is 0.5. And then I'm going to divide by 2. So what that's going to do is it's going to add my 1 plus my 0.5 and then divide by 2 to get this point here. And this is where I'm going to place each one of my labels for my X ticks. And then I'm going to associate those with the values that I've put in my G list. So that's again going to be G1, G2, G3, and G4. But they will be centered kind of where the two bars meet using this little formula here. So if I go ahead and render this one, we can see here we have our maybe first time step with our double comparison, second time step with our comparison, third time step with our comparison, fourth time step with our comparison. If we wanted to have a little bit of spacing, this kind of looks a little mushed together, right? It's a little bit, it could be a little bit difficult or a little unclear as to where everything kind of gets separated. So I can thin out these bars to allow for more space in between them. And what I'm going to do here is simply reduce the width from 0.5 to 0.35. And then anywhere that I had 0.5 in my code, I'm going to update it with my W. So here, I'm going 1 plus 0.35 in order to shift them over 0.35. For my X ticks, I'm going to add I plus 0.35 instead of I plus 5 and divide by 2 in order to figure out this center point here. So if I run this particular code piece, I've got thinner bars, they're separated, and it's a little easier and clearer to read where my data representation is. Another kind of cool thing we can get to play with are called scatter plots, where basically we have two lists within Python. Each of these lists has to be the same length because, again, we're basically creating x, y coordinates. And so if we had one more x, if we had one more element in the x list than we did in the y, then we'd have kind of a wackadoo element. So they do have to be the same length, these lists for x and y. I'm going to use the random module here in Python. There's also a random generator in NumPy as well that I use in some of the later demos. But here I'm just going to go ahead and use the random module so we get different plots every time we run this. It simply allows us to generate random values. So that's what this one is. This is creating a random integer value between the integers of 1 and 10, and it's going to do it 10 times. So y is simply going to be a list of 1 through 10. Y is going to be random values between 1 and 10 duplicated 10 times. And then I'm going to create a scatter plot putting my x and my y together. So x sub 0, y sub 0 will be the first point, x sub 1, y sub 1 will be the second point, and it's going to plot those scatters on my little chart. So here we basically have some random dots going from so the first one that generated was I, and it looks like it randomly generated 10. It did it again. Here we have two 7s, another 10, an 8. This looks like a 4, maybe a 9, a 5, and then lastly we have what looks to be a 3 for this particular chart. So it generated random y values to go with our x values. What we can kind of begin to do with scatter plots is begin to change the colors, maybe make these larger, make these dots particularly larger, and begin to use what I'm going to call an alpha value with RGB in order to kind of see if they overlap in some way, to see where our data might overlap and maybe point out this is where we need to look at something within our data. So we can alter the way our points appear. First off, we can make them large. So here we have s equals 200. So our points went from relatively small to 200 point little dots here. The next thing we might want to do is change the color of our dots. So this is going to generate a bunch of red dots, but that's kind of boring. And sometimes, especially when you're using things like scatter plots, you may want to have the location. So maybe this is temperature and maybe this is time. And we're trying to see if there's some kind of correlation between the color of our dots or the color of something, which could be representing the heat of something visually, right? And there are a number of kind of color sets that we can use or pull from within Matplotlib. I use one of them in one of the lower one of the later demonstrations. So for instance, if we wanted to make something kind of like a heat map, right, where the color of the marker actually relays almost as much information as where the marker is located on our particular color chart. We can perform this type of visualization on our scatter charts by changing the color of the marker based on where it is located on the y-axis. So in order to do that, right, I simply set the color to be y. And so whatever the y is, right, this value here is going to get translated to a kind of RGB value that is associated with that number. So if I run this, good, we begin to go from kind of a dark purple, and then we begin to see kind of bluey purple, and then bluey green, actual green, kind of a yellowy green, and at the very top we have yellow values. So we can see as the Y value increases, the color of our dot changes, which can help us tell all kinds of cool, interesting information about the data that we're kind of looking at. And so this uses an RGB format, red, green, blue, and then alpha, where the alpha is going to determine how transparent or opaque something is. So an alpha of 1 is going to have, it's going to be completely opaque. You can't see through it at all. An alpha of 0 means that the color is completely transparent or completely clear. It's basically window glass. And anything in between is going to allow you to kind of begin to overlap colors and see, which will create kind of a blend of those two colors, and we can see in our data visually where something might overlap, which could be an important thing to kind of look at. So here, what I've done is I've set the alpha to 0.5. I've also made these dots very, very large to kind of enforce that we're going to get some kind of overlap so that we can see what happens as these colors kind of begin to blend because they overlap. So if I hit play here, we can see here, this was actually got a pretty good one. This is the darkest green that we have here. These two kind of overlapping also make a darker green. The yellow overlapping with the green kind of makes a darker yellowy color. But we can begin to see that they blend whenever they overlap. If I run it again, we'll get kind of slightly different colors, but we can begin to see, like this one, we have our two kind of paler purples because of the opacity, but when they duplicate on each other, it creates a darker version of the same color. So this opacity kind of begins to allow us to see where data might overlap visually. Another thing we can do with these particular data points is actually alter the size of our dot based on its location. And this time, again, I'm still going to use the x-axis. So here, what I am doing is I am multiplying I, or this value on the x-axis, by 500 for every, I'm multiplying the value y for every I in y. So if I run this one, we're going to generate different sized dots based on where they're located along the y-axis, which is kind of an interesting thing. So there might be something where you're showing growth that you might use this type of kind of figuring. Another thing you might want to do for your actual data is to say, hey, this particular point is important. Maybe it's an outlier. Maybe you can't figure out why it's there. Maybe it's just like the top of your sine wave. You want to say, this is always going to be the peak of my data. You can annotate that particular point using this annotation function, where S here is the string or the text that you want to use to annotate your point, and XY is the location of that point in coordinate points. So if we take a look here, what I've done, we have a little bit of annotation text. So my S equals annotation text. And then because I am constantly generating random values, what I've set it to do is always simply point to the first value in my set of points. So it's just going to point to x0, y0, or the very first point within my list of points generated here. So my points are going to be relatively large again. They're going to change their color based on where they're at on the y-axis. And I'm going to put some annotation text at the location of this particular point. So if I hit play to take a visual here, we have this point that looks like it's generated about 1,6. And the annotation text is kind of written on top of this point. Useful, but maybe a little bit confusing, because we are actually writing over our data point with some kind of annotation with a little bit of text that we wanted to talk about our data point. So one way to get around this is to actually say, I want to put the annotation text starting at some other point within our graph, and then make an arrow, or what we're going to use arrow props, which is a dictionary within Python, within the Matplotlib library, that is basically a dictionary of line properties for the type of arrow that you want to have pointing from your annotation text to the point that you want to annotate. So let's take a look at how we might point to this point and move our text. So here again, we start off just like we did with our little bit of annotation text, and we are wanting to mark the very first point that we're looking at in this little chart. Here, my XY text, I'm going to start. So the word annotation is going to start at the location 2,5. So at 2,5 is where the annotation text is actually going to start. And then we're going to have this arrow props is our dictionary piece, where the type of arrow that we're going to use is going to be a wedged arrow, and it's going to have a tail width of 1 pixel. So it's going to have a little wider 1 pixel edge, and then it's going to taper down to a point. That's the little wedge thing. So if we take a look at this, we have our little wedged point annotation marker, a little wedge arrow prop here, and then our annotation text starts at 2, 5. I've gotten incredibly lucky with these dots in this random text here, where it doesn't overwrite any of my other dots. But we can see here that our little arrow kind of goes from near the center of our text, but it points to that specific point saying, hey, this is the point that we're talking about. Here's some text about this particular point. So maybe it's an outlier, again, in your data, or at least something that you want to point out. So I've gotten to the point where I'm going to show you guys some kind of cool and interesting figures that you can make using Matplotlib, because at this point you can do some pretty cool things. You should be able to generate a basic chart. You can make line charts, bar charts, scatter charts, and then some of the other things that you can create, but of course still not limited to. I'll have a demo of a histogram, which basically allows you to organize a group of data points into user-specified ranges. We'll take a look at path, which allows you to kind of draw something and then generate maybe a line point representing what might fit within your particular drawing, which is kind of cool. We can also generate pie charts. You can create tables. You can create polar charts as well if you have something that's dealing with a spherical coordinate system. So let's take a look at some of these slightly more interesting kind of graphs. And here again, I said I was going to show you a different way to do subplots where you didn't have to use the 2, 1, 1, 2, 1, 2, where you didn't have to tell it exactly where you wanted everything to be. So another way to do that is to simply have a number of different variables equal to plot.subplots. So this calls this for as many variables as we have here. This one is only going to generate, the fig here is merely there in case I wanted to set this, in case I wanted to generate an image later, or have it create an immediate ping. So here we have just a very simple sine wave. Here I am setting all of the information about my little chart. So I have my X label, I have my Y label, and I've also provided a title for my chart. So I have a simple sine wave, I have time, I have voltage in millivolts. The next one that we can kind of take a look at, I'm going to run this. This is, we're going to take a look at a bivariate normal distribution, which is basically just a distribution on 2 independent random variables. And these guys here, especially the C book, okay, the C book is one of our kind of sub modules here that holds a lot of images. So I can pull various different images from this C book. It's kind of got a library of images, if you will. And so if I take a look at this, I'm going to go ahead. Wait, did I run this? I do need to run this to import all of these things. Okay. Or my charts won't work. So here we have our little bimodal distribution. Another thing we can do with these particular sub modules within Matplotlib is we can actually generate images. So here we have an image that I've pulled of Ada Lovelace. Okay, that image exists basically in the sampled data of our C book submodule. Again, I've got kind of my subplots here where it's going to print this one and then this one. So this one I have pulled a CT basic image, kind of a default image here. And then I have added a couple of points. So if you have an image that you've taken and you want to maybe point at something or kind of annotate something within that image, you can do that as well within Matplotlib, making use of a number of the sub submodules available. Another one that's kind of cool is the P color mesh. Basically, if you have kind of an array of data, this will utilize a color system and tell you various different information about that data based on maybe its size. So it kind of takes the data in an array and colors it for some particular reason. Those are purely random. Another thing you might want to do is kind of bunch up your information into bins. So that's going to be the basic histogram, along with just showing you how to generate a histogram. This will also allow you to show you how to set the number of data bins. It'll allow you to change the density parameter. It'll allow you to set the face color of your bars, in other words, the color that your bars show up as, along with the opacity of those particular bars. I've also got a link to a documentation page here that will help you design a histogram. The AstroPy documentation has a great section on how to select these parameters, these bin counts and sizes, because it can affect how your overall histogram looks. Okay, so here I've kind of got two charts in one. I've got my best fit line. Okay, going through my data and my actual histogram here, where I've separated things into bins. Again, I have a title, right, and an x-axis label and a y-axis label. You can also add arbitrary paths in Matplot using the path. So this is one where we can actually draw pictures, right, and then kind of generate a outer plot line of what's included in those particular pictures. So if you were looking at something like image analysis, you might be able to generate a chunk of an image and then try to determine any kind of correlations with the points around that particular image. So this here, the path is going to generate a picture, basically a very simple shape. And then this piece here is going to kind of create an outer grid line around that shape. So here it creates a kind of sad little heart and then generates a outer line around that sad little heart. This one's in here as an example of a 3D graph. So you can actually generate 3D graphs for things like surface, wireframes, scatter, and even bar charts. This particular one uses the cool warm color map. Okay, so I've gone into my CM. I've imported CM here, my color map, and used the cool warm color map in order to generate this particular plot. So in this one, there it goes. So it creates a 3D image of this data, and it provides me the cool warm color map. So things, of course, lower here are going to be cold. Things here are going to be warmer. We can kind of see what is cool and warm in this particular 3D image. So this last one here is a pie chart. And what's cool about pie charts in Matplotlib is you can actually explode or separate off one of your pie slices in order to kind of emphasize that particular slice. So here I'm going to explode just the second pie slice. Here I have my labels for each one of my pie slices and then the values associated with each one of those labels. So 15 is going to be frogs, 30 is going to be hogs, 45 dogs, and 10 is going to be logs. And then I'm going to set my explosion to explode that I've created here. It will have labels. We're going to set shadow to true, which means it's going to have a little bit of shading. So it's going to kind of look 3D based on the shading. We're going to start the pie separation splits at 90. And then I've set this to equal so that we get an actual circle. And then it doesn't necessarily make some kind of weird oblong kind of shape. So here we have our little pie chart with our offset second slice where we are emphasizing for some reason the hog's piece of pie. And so as an ender, just for fun, I generated Matplotlib. You can generate XKCD style charts, kind of using their text and things, which is kind of fun. XKCD, of course, is a popular online kind of computer-related type comic. So if I run this one, it's kind of a cute little Matplotlib just for fun, where it generates kind of cutesy-looking graphs using the XKCD style. So at this point, I'm actually open for questions.
Amy, like, how well do you feel that the Matplot is documented for somebody that has a little bit of Python experience, but is really trying to kind of incorporate it in their project? How hard do you think it would be for them to figure that out?
I think it's pretty well documented. There are extensive examples. There's a whole thing just for tutorials, just for examples, and it gives you the code and it shows you what the plot should look like. So it really walks you through a lot of the different ways to generate all of these different types of charts. So it's excellently documented.
And one last thing for me anyway is you've been an expo judge. Like, how would kids benefit from using, or how would a project benefit from having Matplot incorporated in it? Because I don't know of many kids that have in the past for their projects. Is there any suggestions or any things that you've kind of seen in terms of supercomputing challenge projects that could benefit from this?
A lot of times when I'm working with my data, seeing it is really kind of understanding what's going on inside of your data. So even if you're just generating basic charts, you can really begin to see what's going on in your data, because it's taken those numbers and it's made them visual. And depending on how you kind of begin to visualize that data, you could really begin to delve into some of the cool portions or cool parts, especially with like one of my high performance computing projects, where we were running something on a shared system, and we would get this really odd outlier, and we had to figure out why that outlier was there. But of course, we didn't notice the outlier until we put everything onto a scatter plot and realized it way out, kind of way out in the boonies. We had to figure out what was going on with that one particular plot. Why were we getting these weird numbers? And until we really put it in some kind of visual measurement, we had no idea that was even there. Oh. Yep. So we are off, I guess, for today. Thank you for joining, and good luck on your projects.